So here we see two transformation. That is, the first transformation is vertical stretch by a factor of 2. So if we consider this function f of x equals root x, and when we apply this transformation, that is vertical stretch by a factor of 2, we write down this as 2 times of f of x, because according to the transformation rule, a times of f of x gives the transformation, that is vertical stretch by a factor of a. So here a equal to 2, so we can write down this as 2 times of f of x, and this equals 2 times of root x. Because we multiply by 2 on the left side, we have to multiply by the same quantity on the right side. So we have done the first transformation, that is the vertical stretch. Now let's do the second transformation, which is the reflection across the x-axis. So when you do the reflection across the x-axis, we have to take the negative of this function, that is the above function. So we have to say, or we have to find negative of 2 f of x, and this is equivalent to multiplying by negative 1 with this quantity. So I'm going to multiply by negative 2 or negative 1 on both sides, so that I get negative 2 times of f of x. So it is negative 2 root x. So this basically is the new function h of x. So we write down h of x equals negative 2 times of root x. So this is the function which is obtained from the function f of x by applying the above two transformations. Let's answer this question. So we are given this function h of x equals square root of 3x plus 1, and we have to write down the h of x in terms of the composite function, that is f of g of x. And by the way, we have to determine the two function f of x and g of x. So basically we have to identify the outside and the inside function from this expression. Clearly, we can see that this outside function is the square root function. So we can see that f of x is basically a square root function. I'm writing down this as square root. And then the inside function is the part or the expression inside the square root function. And this is 3x plus 1. So we can write down g of x, and this equals 3x plus 1. In fact, we can also verify that. So let's see if this satisfies, that is f of g of x. H of x is equivalent to f of g of x. So I'm going to find this expression or the composite function f of g of x using the functions that we identified. So it is f of, now I replace g of x by 3x plus 1, and now we have to find f of 3x plus 1, and this means we have to replace x in f of x by 3x plus 1. So therefore this becomes under the root of replacing x by 3x plus 1, we get under the root of 3x plus 1. So it satisfies this given h of x. So, and this means the f of x is under the root x, and g of x is 3x plus 1.